So one of the critical things about laying foundations for adaptation is to make sure that the land use plans and protecting critical public assets and services are somehow codified into the principles of the strategies built for adaptation. These are again some things that seem intuitive, and yet when economic growth is the priority, many things may get missed unintentionally or intentionally, because economic interest, business interest, developers may end up doing things that are not necessarily in line with laying foundations for adaptation to climate risks, right? So we have to be careful about that. This section, the priority area, is imagined to fit under economy, planning, investment, or infrastructure. So ministries are divided based on the priorities, or whether it's a high income country, low income country, and so on, or medium income country. Here, beyond direct support to households and businesses, governments have a transformative role to play in ensuring their country, their economy, and their citizens can adapt to climate change. This is particularly the case to ensure the adaptation of important public assets and infrastructure systems such as power systems, roads, water and sanitation, and essential services such as healthcare, education, safety, and security. So these have to be protected, and land use plans have to make sure that these are protected as expected, including building resilience. So it's not always a question of just how much investment is made, but that proper principles are used to ensure resilience to climate impacts. Urban and land use plans also influence massive private investments in housing and productive assets. So it's vital these assets adapt to evolving long-term climate risks to avoid locking people into high-risk areas. So if you build too close to the coast or build in slopes which are going to be vulnerable to extreme rainfall events or cloud bursts or winter storms and so on, then people invest in buying a house, then they are locked in for a while. Then insurance and other companies may not stand up to protecting these, or premiums may go up too much, and so on and so forth. So there are all sorts of possibilities of cascading financial problems, economic problems. Under this action 2.1, so we are in priority area 2, so action 2.1, identify critical public services and assets. So you have to know which are critical services and assets to be protected in the planning. Critical public services such as energy, water, healthcare, civil protection, and education need to take a thorough approach to assessing and managing climate risks. Not only can their reconstruction be costly, they also provide critical services which people's well-being depends on. For a systematic risk and vulnerability assessment, governments must develop inventories of key public assets, including primary healthcare facilities, hospitals, and schools. Assessing the resilience of service delivery in critical sectors can also be a useful exercise. In network systems such as transport or power systems, the criticality analysis described in Toolbox C in the main text of this guide, which we'll look at later, can help governments identify the most important assets or system components to invest more resources in their resilience. So here is an example of S4. The criticality of a road depends on how it is used. Critical roads for household consumption here. So household loss in terms of percentage of daily consumption. You can see that depending on where you are, the loss is heavy, so 0.7 here, as low as 0.1 down here in these areas away from this border here. So you have to read this paper from Halligat et al. 2019 to understand how these are defined, but we'll look at it a little bit later on again to understand a bit more. But the critical roads for international clients here can end up in importer loss, so percentage of daily consumption, and again you can see the scale goes from 3 to 1.7 to 0.5 here. So you can see that the same road here has a different household loss versus importer loss, and how to account for both and what is critical for economic development versus protecting people then has to be considered. In action 2.2, design and implement a government-wide strategy to increase the resilience of infrastructure and public assets. There is a consensus among experts that governments have a key role to play in ensuring the resilience of critical infrastructure and that they should adopt a whole of government approach. Infrastructure disruptions in developing countries are estimated to cost firms more than 300 billion US dollars and households over 90 billion each year. So firms lose up to 300 billion, more than 300 billion, and households lose more than 90 billion each year. But if countries have the right data, risk models, and decision-making methods available, the incremental cost of building the resilience of infrastructure assets is small, only around 3% of the investment needs. So in this sense, it's not just the investment, but the proper governance and codes for construction, etc., to ensure resilience. I think you have an intuitive sense of what resilience is. Basically, if there is a perturbation and huge climate hazards like the big typhoon that's now heading towards Taiwan and China comes and destroys infrastructure, for example, of healthcare and sanitation, whatever, then how quickly can the system recover after the impact has ended? So typhoon will come in, it will bring winds and rain and do all sorts of damages, and then it's gone. Then the system is heavily damaged, but how quickly will it come back to being fully functional again? That resilience recovery pathways are very, very important as well. The next action item, revise land use and urban plans to make them risk informed. Land markets, so these include basically taking sometimes the IPCC scenarios, make them region specific, make them about physical risks that can be chronic, like increasing warming over longer time scales, or acute, like a hit of a typhoon, and also transition risks. How do you go from business as usual to adapting to future climate risks? So these are detailed plans that need translation of climate scenarios to economy, infrastructure, and the critical assets that we're talking about. So revise land use and urban plans to make them risk informed. Land markets are powerful tools for driving new construction in a way that efficiently meets population needs. However, they are also imperfect and often fail to fully internalize climate change and natural hazards. In some countries, land markets are even dysfunctional, with most of the population living in dwellings that have informal arrangements and low land use or urban planning. This is very common in a country like India, for example. As a result, developments often occur in risky areas, on slopes with landslides, or near on floodplains and so on, especially when developers do not carry the cost of future climate change impacts. Land use regulations can help by ensuring that new development takes place in safe areas or those that can be easily and cheaply protected. They can also avoid unchecked urban development that leaves too little porous green space, further increasing runoff and flood risk. Okay, so this future planning for the future in terms of risk-informed urban plans and land use is not as easy. It's a question of how careful you are in estimating the risks and what are the uncertainties in your estimates of future risks. Here is an example. Urbanization in Addis Ababa, Ethiopia closely follows the major transport lines. So nothing to do with what climate will do. They are just following transport lines because that's convenient for household importer exporter kind of business, and obviously that increases density in areas which are not necessarily safe from climate risk, especially going into the future. Okay, so these are critical issues to consider. We'll come back and look at priority area 3, underlying foundations, in terms of helping firms and people manage residual risks and natural disasters. So even after everything is done, what risk remains as residual risk, especially under natural disasters and hydroclimatic hazards and so on. Okay, so I'll keep going this way, reading the text and adding some pointers along the way. And this is, remember, this is the summary part. We'll come back and look at these sections again with the toolboxes and some metrics that have to be defined and so on and so forth. Okay, All right. See you in the next podcast in a minute.